Okay, we're back, and let's finish up the endocrine system with it's going to be a pretty short video, just a little bit more to go. And I think well, let's go back when we ended on this one, the insulin disorders. Oh, one thing I wanted to say, that I did mislead a little bit on the last video when we talked about the one of the things that happens in Addison's disease, which is a hyposecretion of cortisol, is a darkening of the skin. I looked that up. I think I misled you. I talked about something, whatever I said was wrong. It's the fact that without any cortisol, the levels of ACTH are like sky high, and apparently they stimulate melanocytes to darken the skin. And this is true for any of these axes. That remember the third hormone feeds back upon the hypothalamus and the pituitary to inhibit the releasing hormones and the stimulating hormones. But if there is no hormone to do that, then those releasing hormones and stimulating hormones go through the roof. So since there's no cortisol being made, it's not inhibiting the anterior pituitary from making ACTH. ACTH goes through the roof. Same thing with TSH. If say your thyroid was cancerous and they removed it and didn't replace the thyroxine, the levels of TSH would go skyrocket in a desperate attempt to get the thyroid gland to make thyroxine, but the thyroid gland isn't there, so it can't make thyroxine. So that's a problem. Okay. Secondly, this insulin thing. So the lack of insulin has a specific disease, diabetes mellitus. No insulin, we have a disease, diabetes mellitus. Well, how come there isn't a specific disease for the like a glucagon, for example? Glucagon is supposed to, it raises blood glucose, and it's one of the major ones that raises blood glucose. But there isn't a specific disease of, in case your alpha cells don't work and you can't make any glucagon. And that's because there's lots, if you don't have any glucagon, there's lots of backups to raise blood glucose. There's lots of hormones that raise blood glucose. Cortisol does, thyroxine does, glucagon does, epinephrine does, lots. So you don't really have to worry about raising blood glucose. But what's the only hormone that lowers blood glucose? Insulin. So there's no backup. So that's why there's really a specific disorder for the lack of insulin. Okay. And not one for the lack of glucagon. Okay. So now we move into a few on aging in the endocrine system. Growth hormone tends to get lower and lower as you grow older, and the sex hormones decrease also, but more for one gender than the next, than the other one. Right? In males, testosterone starts to drop off a little bit in very elderly men, but not that much actually. Although you can't have hormone replacement theory. You can go and buy testosterone supplements if you want. I was even taking one for a while, but didn't do it. I didn't think I really needed it. Anyway, but it really drops off for females, of course, after menopause. Estrogen and estradiol levels really plummet, and they have all kinds of symptoms of hot flashes and things. So then you can get, so they often go for hormone replacement therapy. It's much more serious in females. And late next semester, we'll speculate on why that is. Why is there an end to the reproductive life for females and not for males? Because males make sperm all their life. They can father children and whatever. They only stop making sperm when they die. But females stop making eggs at around late 40s, early 50s. Why? Nobody knows. Anyway. So, and speaking about the gonads, ovaries and testes, right? You might think of them as why not they are, aren't they in the endocrine system? Technically, they're not. There are other organs that that secrete hormones. And the next couple of slides are going to be a bunch of other organs that are not endocrine organs but secrete hormones. Because the major role of ovaries is to make oocytes and to prepare the uterus for implantation. Same thing with testes. The major role of testes is to make sperm, and it secondarily makes testosterone. Okay, so ovaries, they make estrogens, female hormones, and two of those, the most common one is estradiol. And then there's a structure in the corpus luteum called the corpus luteum after ovulation that makes progesterone. And these are permissive hormones, remember. The estradiol helps to prepare the uterine lining for possible implantation before ovulation. And then after ovulation, progesterone is secreted by the corpus luteum, and it really builds up the lining of the endometrium. Okay. Testes, there are cells called interstitial cells in between the seminiferous tubules, that's why they're called interstitial, that secrete testosterone. And what does testosterone do? Supports spermatogenesis, right? And is responsible for male secondary sexual characteristics, is also responsible for libido or sexual desire. That's its role also in females, it supports libido. Okay. So secretion of hormones, well, I just talked about, I could put ovaries and testes here, secretion of hormones from non-endocrine organs. So skin, cholecalciferol is a precursor for vitamin D, and it's activated by UV light to become another molecule that has to go to the liver and has another step, and then the kidney step for another step to finally become vitamin D. Liver makes up several hormones. Calcidol, I think, is what cholecalciferol is converted to in the liver. Once it's converted, once cholecalciferol is made in the skin, it goes to the liver, made into calcidol, and then I think it goes to kidneys to become calcitriol, which is vitamin D. I think. Angiotensinogen is, we'll talk about that next semester, where it is a hormone that can be, it's an inactive hormone, but that can be converted to an active one by an enzyme from the kidneys and an enzyme from the liver to become angiotensin 2. And it has a bunch of effects we'll talk about next semester on blood pressure. Erythropoietin in kidneys too. When you have low red blood cell count, or you have anemia, the kidneys and liver will detect this, make EPO, which is erythropoietin, find its way to the red bone marrow and stimulate red blood cell production. Insulin-like growth factor, we talked about growth hormones, stimulates the liver to secrete insulin-like growth factor, which leads to growth in muscle and bone in other places. Hepcidin is a pretty much new liver hormone that discovered not that long ago that actually inhibits iron absorption. It prevents iron is absorbed into the enterocytes lining your small intestine, and it's trapped there if hepcidin is present, because hepcidin won't let it get out. And then that cell will be sloughed off, and that iron will be lost in feces. But if you're low on iron, liver will stop making hepcidin. It'll open up these ion channels, and iron will come into the blood and be brought to the red bone marrow to help make red blood cells. Kidneys, as I mentioned, calcitriol, vitamin D, erythropoietin. Renin is considered a hormone, but it's actually also an enzyme that converts angiotensinogen from the liver into something called angiotensin 1. The heart, atrial natriuretic peptide. The heart has baroreceptors that will detect blood pressure. If blood pressure is too high, the heart will secrete ANP, or atrial natriuretic peptide, and this will lower blood pressure by inhibiting salt reabsorption and therefore inhibiting water reabsorption in the kidneys. Therefore, your blood volume will drop, your blood pressure will drop. So it's one of the few hormones that lowers blood pressure. There's a whole bunch that raise blood pressure, but ANP lowers it. What raises it? Aldosterone will raise it. Angiotensin 2 will raise it. Thyroid hormone, I think we can raise it a little bit. Epinephrine certainly will raise it. Okay. Going on still farther, stomach and small intestines, a bunch of what are called gut-brain peptides, because they're produced in the gut and they affect the brain. One is called cholecystokinin, gastrin, ghrelin, and peptide YY. Well, gastrin stimulates the stomach, all right? So it's secreted by the stomach, and it stimulates the stomach. Cholecystokinin stimulates the contraction of the gallbladder. It also inhibits hunger. It's a satiety factor, along with peptide YY. So a full intestine will secrete peptide YY, will feed back upon the hypothalamus, where your satiety center is, turn off hunger. But an empty stomach will secrete ghrelin, and that is the hunger hormone. That tells you, hey, you're hungry, eat something. Right? Adipose tissue secretes leptin, which is also a satiety factor, but it's more importantly, it's a signal to your brain as to how much fat you have. It's both in males and females, but it's much more important in females, because females have more fat than males, and there's a good reason why they have more fat. They may have to support another life form. A female's brain really has to know how much fat she has. Osseous tissue, osteocalcin, secreted by osseous tissue or bone. And it's strange that it stimulates insulin. It has an insulin stimulating effect. And I never really understood that, why we have that connection. Okay, the placenta, well, is something that's only found in a female body, secretes estrogens, progesterone. Well, placenta will secrete progesterone after about 3 months or so. For the first 3 months, the corpus luteum continues to make progesterone. And the corpus luteum is, we'll find next semester, late next semester, the corpus luteum is going to disintegrate on about the 25th to 26th day of the cycle, if HCG is not made by the placenta to prevent, it's called human chorionic gonadotrophin. It stimulates, it maintains the corpus luteum so that it continues to make progesterone for the first 3 months of pregnancy until the placenta itself can make progesterone. Why that is, I don't know. Why an early placenta can't make progesterone, I don't know. And finally, the newest one that I discovered is in skeletal muscle. Even skeletal muscle makes a hormone they're called myokines. It's one of the really benefits of exercise, because the more you exercise, the stronger your muscle gets, the more myokines are produced. And they tend to reduce overall inflammation in the body. So that's one of the real healthy benefits of exercise, is to making these myokines, because widespread inflammation is a really dangerous thing, a really unhealthy thing to happen. So, okay. We'll also find out that exercise is one of the best ways to reach HDLs, high density lipoproteins, which are the good cholesterol. That takes cholesterol out and disposes of it. So those are two great effects of exercise. Okay, I think that's it for endocrine. That's it. So this is 203 endocrine, endo4, and we're done with the endocrine system. Okay. I'll see you later. Catch you on the flip side. Let me stop recording here.